Hello, dear students. Welcome to Massive Open online course English for Mining Engineering, Module 1, Rocks of the Earth's Crust and Useful Minerals. Last time we spoke about groups and formation of mineral deposits. This time we are going to study weathering. 3.1 What is weathering? 3.2 Types of weathering. 3.4 Physical weathering. 3.5 Chemical weathering. The course was created by Senior Teacher of Foreign Languages Department, Master of Economic Sciences Yarema Tatiana Vladimirovna. Okay, let's start. 3.1 What is weathering? Weathering is defined as the process of decay and disintegration of rocks under the influence of certain physical and chemical agencies of the atmosphere. The force of the blowing wind or the design waves may cause mechanical wear and tear of rocks exposed to the fury. Similarly, rocks exposed to heating temperatures of the sun in deserts gradually disintegrate into smaller pieces. In addition to the above physical breaking down of rocks mass, the same is often subjected to reaction with running underground water enriched with chemically reaction substance. Under such conditions, some of the constituent minerals forming rocks may be removed in solution, and as a result, the rock becomes weak and is naturally more susceptible to further physical disintegration. 3.2 Types of weathering. Various factors that affect the rate of weathering are climate, photography, structure, texture, and mineral composition of rocks, vegetation, cover, and time. Depending upon the agents of weathering, it can be of following types. 1. The physical weathering and chemical processes of disintegration. 2. Chemical weathering of chemical processes of rock decomposition. 3. Biological weathering or disintegration of decomposition associated with the activities of organisms. Physical weathering. The physical weathering is a mechanical disintegration of rocks into smaller fragments and particles without changing their mineralogical composition. The factors which are responsible for the physical weathering of rocks discussed below: temperature variation, unloading, crystallization, frost action. Let's study temperature variation. The weathering due to the temperature variation is referred to as thermal weathering. This phenomenon, also observed in all climatic regions, is more intense in arid, desert, and semi-arid regions, where summer and winter temperatures differ considerably. Rocks, of course, are bad conductors of heat, but even then, prolonged exposure to direct heating by the sun causes appreciable volumetric changes in them, especially the outer shell of the rocks expands and contracts with the periodic rise and fall of temperature. This periodic expansion and contraction of rocks leads to the formation of cracks parallel to the heated surface, and then flaking off the upper layer. This process of peeling off the upper layer of rocks is known as exfoliation. Unloading. Most of the igneous and metamorphic rocks formed at great depths under conditions of high temperature and pressure. The pressure exerted on a deeply buried block of rock by the overlying materials is enormous. When this overlying rock cover removes due to denudation or erosion, the pressure on the cover of rocks removes due to denudation or erosion. The pressure on rocks beneath them diminishes, and due to this unloading, rock blocks adjust themselves by upward expansion. This results in the development of the closely spaced joint system and fractures parallel to the surface. Sheets between the fractures get to detach from the main mass of rock, which further fragmentation. Crystallization. Water, along with many soluble minerals constituent, enters the rocks through its fractures and joints. When water gets evaporated, the salts it contains start crystallizing. As the crystals grow, they exert large expansive stresses, which results in the weakening of the rocks and ultimately their fragmentation. Frost action. The volume of water increases by about 10% when it freezes. Water trapped into the fissures, pores, and crevices of rocks and exert pressure at the rate of 2,000 pounds per square inch on the walls in the fissures during its freezing. A freezing cycle is often followed by a thawing cycle, the melting of ice formed with the cavities. During the first stage of the attack, the openings get widened, allowing more and more water to accommodate during subsequent cycles. This alternative freezing and thawing results in the gradual disintegration of rocks. Chemical weathering. The mineral constituents of rocks are generally not in chemical equilibrium with the atmosphere around them. The chemical reaction between the surfaces of rocks and chemically active constituents of the atmosphere, water, carbon dioxide, nitrogen, hydrogen, and oxygen, refers to as chemical weathering. The chief chemical weathering processes are hydration and hydrolysis, oxidation, carbonation, solution. Hydration and hydrolysis. The surface of many crystals is not in electric equilibrium. They may have the partially unsatisfied valencies. When polarized water molecules come in contact with these crystals, either hydration or hydrolysis may occur. When mineralization tends to hold the polarized side of the water molecules and forms a hydrate, the process known as a hydration. This addition of water leads to a change in the mineral composition of rocks. Hydration causes swelling of some minerals, which in turn produces more stresses within the rocks. The most common example of hydration is the conversion of anhydrate. Oxidation. The free oxygen of the atmosphere and the air dissolved in the water is the most active chemical reagent. Iron, which is the main constituent of many minerals, and rocks get until with the free oxygen and from oxides, thus altering the composition of rocks. Carbonation. Carbonation is a process of adding carbon dioxide to minerals to form carbonates. The carbon dioxide present in the atmosphere gets dissolved in rainwater and forms a weak acid called carbonic acid. The carbonic acid, which reacts with several minerals, dissolves carbonate present in the rocks. Solution. Some of the minerals present in rock may get dissolved in water and thus removed by solution. However, pure water is an effective solvent for most of the rocks, but when it is carbonate, the effectiveness of the solution processes enhances. So, dear students, that's all for now. Next time we will study metamorphic rocks. Thank you for your attention very much. See you the next time. All the best.